Question 4 says the function si of x, which is defined as the integral of sine t over t from 0 to x, is called the sine integral, and it happens to appear in the theory of signal processing. All right, now notice that this integrand sine t over t is not defined when t is 0 because of the division by 0. And since 0 is our lower limit of integration, this is actually an improper integral. Okay, but noting that since the limit as t approaches 0 of sine t over t is equal to 1, we showed this in question 2, okay, the integrand sine t over t is typically defined to equal 1 when t is 0. Okay, and so what that does, it effectively removes the discontinuity. Okay, so here's a graph of sine t over t. Okay, and you can see there's this hole here when t is 0 because of the division by 0. And since the function's nicely behaved around 0 and it has a limiting value of 1, if we define the function to equal 1 at 0, we remove the hole, so to speak, right? We remove the discontinuity. All right, so in any event, let's look at part A. It says compute the derivative si prime of x. Okay, so here we're really differentiating this definite integral. Okay, and so to do that, we want to go back to the fundamental theorem of calculus part 1 that says the derivative of this definite integral of f of t from a to x is equal to just f of x, right? So in other words, the derivative and this integral are effectively undoing one another. Okay, so these are inverses of a certain sort. All right, so applying that result here, okay, I'm just going to evaluate this integrand, sine t over t, at x, and that gives us sine x over x for this derivative. All right, now for part B, it says find the Maclaurin series for SI and find the interval of convergence. All right, so the idea here is to trade in sine t for its Maclaurin series, and that's t minus t cubed over 3 factorial plus t to the 5th over 5 factorial, and so on. And now I can go ahead and divide each term in the numerator by t. That gives us 1 minus t squared over 3 factorial plus t to the 4th over 5 factorial, and so on. Okay, now we can go ahead and integrate term by term. That gives us t minus t cubed over 3 times 3 factorial plus t to the 5th over 5 times 5 factorial, so on and so forth. And then we're going to evaluate this series at x and then at 0 and take the difference. Okay, now when we evaluate it at x, we're really just replacing t with x, so we just get this series here. When we evaluate at 0, well, we're just going to get 0, right? Because all these terms will drop out. So this is the result of this evaluation. And now we're looking at the Maclaurin series for si of x in expanded form. Here is the series in sigma notation, so we're summing -1 to the n to give us the sign alternation, and I'm starting the index at n equals 0. For the exponents on x, right, that's 1, 3, 5, 7, and so on, those are the positive odd integers, so I have a 2n plus 1 there. And then in the denominator, well, I have the positive odd integers, and then those are being multiplied by the respective factorial, right, of the positive odd integers. So I have 2n plus 1 times 2n plus 1 factorial. All right, so that's our Maclaurin series in sigma notation. Okay, and then what about the interval of convergence? Well, going back to the Maclaurin series for sine t, this series converges to sine t for all t. Okay, and carrying out these operations is not going to affect that interval. And so here we conclude that the interval of convergence for this Maclaurin series is all x, right? So, from -infinity to infinity. All right, cool. Now for part C, it says approximate the value si of 0.3 using the first 3 non-zero terms of the Maclaurin series for si. All right, so si of 0.3 by definition is the integral from 0 to 0.3 of sine t over t. Okay, and kind of like the last question, there is not a nice Calc 2 approach to computing this integral. Okay, so like e to the negative x squared over 2, sine t over t is the type of function that we cannot write down its antiderivative in terms of what I called elementary functions, okay? So nonetheless, we can approximate this integral using our Maclaurin series from part B. And so here, I'm just going to take the first three non-zero terms of this series, so x minus x cubed over 3 times 3 factorial plus x to the fifth over 5 times 5 factorial, and evaluate them at point 3. Okay, and that gives me the value 0.298504045. All right, so now if you feed that integral to, say, Wolfram alpha, okay, notice it spits out, for its approximation, 0.298504. Okay, so we're doing really, really good, and we're only using the first three non-zero terms of this series. All right, now that's going to do it for this question. I will see you in the next video.